Natural gas is a fossil fuel formed from when layers of buried plants and animals are exposed to intense heat and pressure over thousands of years. This natural gas is odorless and invisible, and it burns cleaner than coal and oil. Natural gas is used for fuel in vehicles, chemical feedstock in the manufacture of plastics and other organic chemicals. It is used in homes and communities for space heating, water heating, and electricity as well. At the site of natural gas recovery, a vertical well is drilled approximately 6,000 feet straight down into the ground until the shale is reached. While drilling the well, the drill is kept cool and lubricated by pumping a pressurized mud solution down through the drilling pipe, through the drill head, and out of the 3 jets. This removes the cuttings up and out of the well. Once the drill locates the shale, the drill changes direction and the hole is drilled horizontally approximately 1,000 to 3,000 feet into the shale. Once drilling is complete, the mud solution and cuttings are sucked out of the hole and the drill is removed. The steel casing is then fed the entire length of the well. The casing is then secured in place by cement. The cement is pumped under pressure to the end of the pipe so that there is no cement within the inside of the casing. This is shown right here. The drill is then sent down the casing where it drills through the cement and into the shale. Once again, the mud solution and cuttings are sucked up and out of the well and the drill is removed. Perforated pipe gun is then sent down and out of the casing and into the newly drilled section of the well. This is where explosives are then fired from the gun throughout the perforations and into the shale. Then fracturing fluid is then pumped from the surface facility down the tube and into the fractures. The fractures crack, expand, and branch out, allowing the natural gas to be extracted more easily. In multi-stage fracturing, a plug is installed before the entrance of the recently fractured area and the process is repeated. This is where the fracturing and plugging process is repeated the entire length of the well to maximize natural gas extraction efficiency. Once all fractures are completed, the plugs are drilled out and the natural gas is able to flow, allowing for extraction. The natural gas is then pumped up the well to the surface facility for processing.
Natural gas is useful for a number of reasons. It can be burned to produce energy. You're, I'm sure by now, familiar with the idea of climate change, that every time we burn a fossil fuel that contains carbon, we release carbon dioxide into the atmosphere. Okay? That carbon dioxide has been released over the last 100 or 200 years to an unprecedented rate by us. Okay? Since the Industrial Revolution burning coal, to where we adopted oil, to now where we have natural gas as well. Okay? Every time you do that, you put more carbon dioxide in the atmosphere, and we exacerbate the problem. So on the one hand, you can say that carbon dioxide has a big negative to it. Okay? I'm sorry, natural gas is a big negative. Every time you burn natural gas to make electricity, you are making this other problem worse. Okay? So that's one thing to keep in mind. Some of the other things we burn, okay, like oil or coal in particular, actually put, for the same amount of energy, put more carbon in the atmosphere. So you could say that one benefit of cheap natural gas is that it makes coal or oil seem relatively expensive, and it doesn't seem like the effort to make, there's less reason to go through the effort to make a coal plant if natural gas is quite cheap. Okay? And some people would argue that you can make coal clean, but for the most part, coal is a very dirty fuel source. It produces a lot of mercury emissions, sulfur dioxide emissions, and more carbon for the same amount of energy than natural gas is. So cheap natural gas would seem to be a great win. Okay? On the other hand, very cheap natural gas means that it's now cheaper to make electricity through natural gas than to use something like solar or wind. And those would actually produce no carbon dioxide. So it's kind of a funny situation. Cheap natural gas, or abundant natural gas, on the one hand makes things like coal kind of go away, which is a partial win. But on the other hand, it makes it even more unlikely that we're going to invest a lot in solar, wind, geothermal, tidal power that are much cleaner technologies. And so in that case, it's kind of dragging us back and slowing us down. So that's what cheap gas does. It makes things, it changes the balance.
I'm Jessica Varsha. I'm a Senior Research Associate at the Regional Economic Studies Institute here at Towson University within the Division of Innovation and Applied Research.
To get started, my first question is, how does natural gas extraction benefit the U.S. economy, in your opinion?
How does it benefit the U.S. economy, in my opinion? Well, I would say, like most things that generate employment, it's an economic development strategy, and it may, some experts say, make the United States more self-sufficient rather than having to, import, certain types of extractive resources. There's always the flip side, and there's criticisms of that as well. But I would say, for the most part, it's probably the creation of additional jobs and economic activity in those regions where that extraction is taking place.
What impact does natural gas extraction have on the environment?
Sure, it's a really good question, and it's interesting that you asked that because we've been contracted by the Maryland Department of the Environment to conduct a comprehensive economic impact study of potential drilling in the Marcellus Shale in western Maryland. And so, as you probably already know, this type of unconventional natural gas drilling in shale formations is fairly recent. It's been taking place out west for probably a decade or more, but on the East Coast for probably a little less than a decade, with Pennsylvania being probably the forerunner. And so as a result, Maryland is interested in estimating what the potential economic and net benefits or consequences will be to the economy. And as part of that, we are looking at potential environmental impacts, which oftentimes are difficult to value. So for instance, we're using a contingent valuation methodology where we are using a survey to ask residents and visitors to the area to elicit their willingness to pay for certain environmental values that don't necessarily have a value on the market. And those things are like scenic view sheds, because oftentimes the Marcellus Shale areas are largely rural. The landscape may or may not be industrialized already. There might be some history of extractive industry, but we are finding in a place like Western Maryland that there's a high value placed on the pristine environment and the condition it's currently in. So as a result, we're conducting the contingent valuation analysis, and we're also looking at the impact that there may be on property values before and after drilling, just because there is some risk to groundwater, and as a result, in rural areas, a lot of people are on well water as opposed to municipal water. So, it's really important to do your studies and get your baseline to see if there's impacts to groundwater, which is perceived as the biggest risk from Marcellus Shale drilling. There's some other risks associated with it that are documented in some areas. Potential, air emissions, truck noise, and impacts to the roads and that sort of thing. So those are the things we're taking into account, and to see whether or not they'll actually accrue to Maryland.
Natural gas impact on the U.S. economy. Natural gas extraction creates less dependency on foreign oil because there has been 3,400 trillion cubic feet of natural gas found in North America. Shale gas production alone will create some 1.5 million jobs by 2015 and 2.4 million by 2035. This will bring about opportunities for investors and corporations. It has contributed nearly $19 billion in tax and royalty revenue at the state, local, and federal level in 2010, and in the next 25 years that number could exceed $933 billion to states and the federal government. It will become a significant U.S. export in the short-term future. Consumer choice will be more diversified in the future, allowing for gross domestic product projected to reach $118.2 billion in 2014. To conclude, the future of natural gas is encouraging and important to the U.S. economy because it significantly reduces dependence on foreign oil from major importers to exporters of energy. As a result of the speed and scale of shale gas development, a heightened awareness of natural gas as a key component of indigenous energy supply has emerged, and the price of natural gas lowered beyond expectations. This has led producers to seek new markets for natural gas, such as an expanded role in exporting and transportation.